how can we create attribute control charts in Excel, and specifically a P chart? So in order to create a P chart, we need to collect some initial samples of data. So if you recall, we need to collect a large sample every time unit, let's say every day in this example. And the sample size in my example is 1000 units. So what I'm saying is I test 1000 units produced or 1000 services that occurred, and I count the number of defective units among those 1000. So let's say I collected here a sample of, right, 10 over 10 days. I had one defect on day one defect on day two, three defects, five defects, and so on the following days. I have 10 values. So the first thing we need to calculate is percentage or proportion of defects. So I need to calculate this as equal to number of defects divided by sample size, and I press F4 here to fix the reference to sample size so that when I copy it down later on, it does not change. So of course, this is going to be 0.001, and I'm going to now copy it down there, and you'll see every time it is dividing by 1000, whatever the number of defects on the particular day was. Now, the next thing I need to calculate is the average of those p-values in order to have the central line on the control chart. So I will calculate this as average of the p-values. I only calculated once, so I'm not going to fix any references here, and I will add just one more digit to show you that the value is, or maybe two more, the value is 0.00220. And I will also calculate the estimation of the standard deviation, which is square root of p bar multiplied by 1 minus p bar and divided by sample size 1000. Again, I'm not going to fix any references here because this will be calculated just once, right? And this is the value. We can keep it as is. And now I'm ready to calculate the upper control limit. If you recall, this is the mean plus 3 times standard deviation, sigma hat, or estimation of standard deviation. And the lower control limit is, again, the mean, but minus 3 times standard deviation. However, if that's negative, right, I should change it to 0. I'm going to put a general formula here, make this maximum of 0 and this calculation, and that will give me 0 in this case when this becomes negative, right? So when this value is negative. Now what I need to do is the p bar, the upper and lower control limit, they should stay constant throughout. And because I need to plot lines, and it's easier to plot horizontal lines on a scatter chart or line chart just by repeating the value, I'm going to just say this equal to this value, and just again here, same thing, equal, 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 and then I'm going to copy those values down there, right? So basically every time I just take the value that was calculated above, and so all those values will actually be equal to this initial value. Oops, not what I wanted. This, right? So basically here we have identical values. There is some redundancy here, but thanks to this, I will be able to plot horizontal lines in addition to the proportion of defects. So now I can, for example, select this range and insert a scatter chart. So to insert the scatter chart, I'm going to go to Insert, and let me actually select a larger range, a few more rows here, so that I can it will be easier for me to add new points later on. And I will say Insert and Scatter Chart. Notice the first column is taken as the horizontal values for the horizontal axis, which is day, and then the remaining ones are plot. But because some of them are not necessary, I will not need the number of defects. I'm just going to delete it. And then you see I also don't need sigma hat, which is this line. I'm just going to delete it. And you see now I have all the values that I need, right? This is the P, or I can actually put a legend here. This is P chart, right? We see here the P value, in this case, this is the gray, P bar, the central tendency. We see the upper control limit. We see the lower control limit, which is at 0. I'm not sure if I can click on it. Right, the 0 is on the lower control limit, and we see the p-values, which are something that we want to control, right? So the p-values show us now that the process seems to be in control. The lower and upper control limits, if they are here, these percentage of defects or proportion of defects is within the control limits. And of course, again, the point of creating this chart is to have it updated in the following days. So perhaps I'm going to extend it for some additional days, right? And the the values of the average upper control limits and lower control limits, they stay the same. So the values should be the same here. And now suppose on day 11, I count the number of defects and it's 4. And you see there will be a new point added here. Let me actually change the here add the markers, not the line, but markers, marker options, put the squares and close this. And you see now I have squares. So now I just added a new point for day 11. I put the number of defects, the average, sorry, the percentage defects was calculated. Actually, Excel automatically entered the formula, right? And I see there's a new point here, right? Maybe on day 12, there is one defect. And again, a new point is added here now for day 12. But suppose on day 13, I see 9 defects. And of course, 9 defects means proportion is 0.009, and that's above my blue line, which is the upper control limit. And that indicates that there seems to be a problem with the process, because under normal circumstances, if there are only common cause variations, we should expect no more than this many, right? The proportion of defects should not be higher than 0.00664 according to this, right? So within 3 standard deviations, we should be no higher than this value, and that means there must be something wrong. Very likely, we should investigate, find an assignable cause, and fix whatever the problem that caused this increase. Fix that problem and avoid, hopefully, quality problems with that approach.